All right, so I just wanted to finish up lesson 2.6. So this is example 5 in your notes packet, irrational roots. So recall what an irrational number is. Okay, an irrational number is a number like the square root of 3 or pi, or the number that we use e to represent, or any decimal that does not end and does not repeat a pattern. Okay, so 0.3 repeating is a rational number because it can be written as the fraction 1 over 3. All right, 0.75 is a rational number because it can be written as the fraction 3 over 4. 2 is a rational number because it can be written as the fraction 2 over 1. And rational numbers can be both positive and negative. So I could put a negative sign in front of this and it's still rational using the same line of reasoning. Okay, it's still a number that can be written as a fraction. Okay, so determine all possible roots. Coefficients of factors of p divided by factors of q. So p plus or minus 1 plus or minus 2. Q plus or minus 1 plus or minus 3. So your possible rational roots would be plus or minus 1 divided by 1, plus or minus 2 divided by 1, plus or minus 1 divided by 3, and plus or minus 2 divided by 3. Okay, so to determine the zeros, we plug all of those 8 values back into the original. Okay, I'm going to save you the headache. P of 1 isn't going to equal 0. P of negative 1 isn't going to equal 0. P of 2 isn't going to equal 0, and neither is P of negative 2. Okay? P of 1/3 isn't going to equal 0. Neither is P of negative 1/3. And then our last possible rational roots, P of 2/3 won't equal 0, and P of negative 2/3 won't equal 0. Okay, so now what? It doesn't mean that a root doesn't exist. It just means that the root isn't a rational number. Okay? So if we had the graph of the function, we could easily determine where the x-intercept is. We don't. But I'm prompted to answer the question, show that between P of 0 and P of 1 there is an irrational root. Okay, so P of 0, if I plug 0 in for all my x's, I'm left with negative 2. If I plug 1 in for all of my x's, I have 3 minus 4 plus 5 and then minus 2. Negative 1 plus 5 is 4. 4 minus 2 is positive 2. Okay, so look at what's happening here. I have no idea what this graph looks like, but I know 0, negative 2 is a point on the function, and 1, positive 2 is a point on the function. So if I just look at that, if I were to connect these points, then look at what happens. Then the graph has to cross the x-axis somewhere. I don't know what the value is, but I know it's going to be between 0 and 1. So your justification in words, since P of 0 is less than 0, okay, the one y value is negative, and P of 1 is greater than 0, my other y value is positive, then an x-intercept or a root or a solution or a 0, right? All those terms are interchangeable. An x-intercept must occur between 0 and 1. It's just not a rational number, okay? So it can't be something that we find using that theorem, or rational root theorem. Okay, last 2 examples, and hopefully you're seeing that some of the topics from Unit 1 are repeating themselves. So now we're determining points of intersections of polynomial functions. In Unit 1, you determine points of intersections between quadratics and lines. So now we're going to look at other types of polynomials. Okay, points of intersection. Set the two functions equal to each other. All right, they're both set equal to y in their original form. All right. Before I can solve any type of function, I get that equation equal to 0. All right, this is trinomial and it's in our quadratic form. So I'm going to attempt to factor it. Factors of 9 that add to -6 would be -3 times -3. But now it's that quadratic form, so now I have x squared and x squared as the first terms of my factors. All right, that equals 0. So now check this out. X squared minus 3, quantity squared. So my answers are each going to be double roots. So I just have one equation to solve. X squared equals 3. So x equals plus or minus the square root of 3. Each are double roots. So if you went to graph that, at both square root of 3 and negative square root of 3, you would have bounce points. All right, but it says find the points of intersection. So I have an x-coordinate of square root of 3 and an x-coordinate of negative square root of 3. So how do I find my corresponding y? I go back and plug it into the original. Please recognize all that you're given. Y is equal to 9. This is a horizontal line through -9. So what's the greatest thing about that? Oh, why isn't this working? There we go. That's going to be my corresponding y coordinates. You don't have to go back and plug it into the other function. You're literally already given what the y coordinate would be. So square root of 3 comma -9, negative square root of 3 comma -9. And I promise if you go back into this 4th degree polynomial and plug in square root of 3, you're going to get -9 as an output. Okay, so now points of intersection. Now both of these are functions whose graphs would not be horizontal lines. So I'm going to subtract 3x. That gives me a -4x equals 0. This factors really nicely. GCF of x, leaving me with x squared minus 4. I'm just going to continue to factor so you see the practice. Difference of perfect squares, so x minus 2 times x plus 2. So I have 3 x coordinates, 0, 2, and -2. So those 3 x values correspond to 3 ordered pairs, 3 points of intersection. So now to find the corresponding y values, you just have to plug it into one of the two functions that are given. I'm going to plug it into the line because it's much easier to substitute. So 0, 0, 2, comma 6, -2, comma -6. Okay? If you were to plug it back into into the other one though, x cubed minus x, and I recommend that you do that, you can verify that you get the same y values. Okay, that's it.